Okay, so happy Thursday. We're going to cover a couple sections today. The first one is going to be our last section from chapter 3, which is rational and polynomial inequalities. We're going to start with example B. I didn't print out the handout for example A, so we're going to start here. So this is going to be a polynomial inequality. We've got a polynomial on the left-hand side. We don't have to multiply it out. In fact, we like it like this a little bit better. And then we got to decide, when is this inequality true? So for what values of x does this inequality make sense? Where is it true? Now the big difference between this and solving equations is that we're dealing with an inequality, and you're going to end up with an answer that is going to be an interval, or maybe a couple intervals. So you should be prepared to answer in intervals. Now, let's take a look at the graph of this polynomial. So I'm just going to call this thing p of x. I asked you a moment ago to put this into your calculators, just the left-hand side. And for giggles, let's make that a less than or equal to, just to try and make you think a little bit more about your answers here. So let's think. We can graph this polynomial. And this is what the graph looks like. Now this is on Desmos. It's easier for me to graph this on Desmos than it is the graphing calculator, but we will get to that in just a minute. But now let's figure out what we're looking for. You know, what it is that you're looking for. And let's see. So our inequality is asking us for where this is less than or equal to 0. You know what? I think I made a little mistake on my Desmos here. I think I've got this for greater than or equal to 0. So, all right, we're going to have to change that one last time. My apologies. Let's make this a greater than or equal to 0. We want to know where this polynomial is greater than or equal to 0. So if you're looking at the graph, where it's greater than or equal to 0 is going to be where the graph is above the x-axis. Now, can you picture that? If you can't, then maybe you got the Desmos link open. You can bust that out and press this. And now that's that highlighted area, that's where the graph is above the x-axis. And so what we've got to do is we've got to write down the intervals that satisfy our inequality, which is where I have these intervals highlighted in blue. Now let me make that a little bit easier here. Let's just put the actual intervals here. So to the left of -8, well, the graph is below the x-axis, so I don't want that interval. But I do want this interval between -8 and -8/3, so that's going to be part of my answer. How about this next interval, -8/3 to 6? Should that be part of my answer? Is the inequality above the x-axis in this interval? No, it's not. How about to the right of 6? Should that interval be part of my solution here? Yeah. So I want the intervals where this is above the x-axis. Now, coming up with a good graph is not always that easy. If you've got this in your graphing calculator, I don't know what your window settings are. Here are mine. But, did I get a good graph on this? That's not a very enlightening graph. Now I can try and make this a little bit better. In fact, one of the things you might notice is that some of the important points are going to be where this inequality actually equals 0. So let's look at those points. Where does this actually equal to 0? Let's find those places, and then we'll see what else we can do in terms of solving this. So let's see, we've got x minus 6 times x plus 8 times 3x plus 8. And I want to know where that's actually equal to 0. Okay, so let's work with that. Well, a couple of these you should be able to read off, right? So we've got this times this equals 0. What makes the first term equal to 0? x equals 6. Dominic, how about the second term?
X minus 8.
And the third term?
X equals negative 2 over 2.
Nice. So these are the points where the actual graph crosses the x-axis. And what would be nice to know is what's in between. Now my viewing window currently isn't wide enough that I could even see these, so that's why part of why my graph looked a little funky. So let's see if we can't figure out that. I'm going to go from negative 10 to 10 on the x-axis. Maybe that'll be enough for me. I'm thinking that this is still not going to be enough here, negative 10 to 30 on the y-axis. So maybe if I go negative 50 to 50, but even then, I still don't think that's going to be enough. Let's take a look at our graph. Okay, you can kind of see a little bit about what's going on, but it's still not perfect. So let me make this a little bit easier for us. We don't have to look at the graph at all. All we have to understand is where this graph can change signs. And it can change signs at these points. So let's put these points on our number line. So we've got a point at 6, we've got a point at negative 8, and we've got a point at negative 8/3, which is about here, negative 2 2/3. So this is where the graph can change signs. Now the question is the graph positive or negative in these intervals? Well, let's find out. Let's check it out. Now there's a nice easy way you can check this out. So I'll show it to you on Desmos first, and then we'll look at it on the graphing calculator. So on Desmos, what we're going to want to do is we're going to want to pick values of x that are in these intervals. So we want test points. And let's take a look at our test points. Test points. I want a value of x in the intervals from 6 to infinity. Can anyone give me a value of x out here? Yeah, 7, sure. How about something between negative 8/3 and 6? What would be another good test point? That's a very simple one. 0. Yeah, 0. So 0 would be a good test point. I need 2 more. I need one for this interval and one for this interval. So how about something in this interval? Negative 3? Sure. And then how about negative 9? Those would be my good test points. Let me show you why this works with my little link on Desmos. So when I do my test points, let's start with negative 9, and then let's see where else. Negative 3, 0, and the last one would be 7. Those points are right here, and here, and here, and here. And what you see is that the sign of this, whether it's above or below the x-axis, is reflected in the y-coordinate. It goes negative, positive, negative, positive. And that's the information we're looking for. We want to know, where is it positive? Where is it negative? That's what's going to tell us what our answer is going to be. So let's write that stuff down. It's going to be negative here, then positive, then negative, then positive. So great. Which interval or intervals do we want? Well, let's actually realize what the intervals are. The intervals for the first one, that's going to be negative infinity to negative 8. So let me see. So it's negative infinity to negative 8. I'm going to put a bracket because I can use the endpoint. I can use that negative 8. Negative 8 would just mean I'd have 0 is greater than or equal to 0. That's true. This next interval is negative 8 to negative 8/3. And then negative 8/3 to 6. And finally, 6 to infinity. those are my intervals. But I only want to choose the ones that actually satisfy the inequality. And that's going to be where this is greater than or equal to 0. So that's going to be this interval and this interval. And you can see it graphically. And that's fine if you take a look at it and kind of solve it graphically. But sometimes graphing these things gets really, really difficult in terms of being able to figure out where you have to set up your window. So the trick is not to worry about that part. All you need to worry about is the signs here. So if you've got this function plugged into your calculator, let's see about testing the signs in a very user-friendly way. Make sure that your table setup is the way it's supposed to be. So hit the second key, then the window key. Make sure independent is set to ask and dependent is set to auto. And now we can do the same thing here that we did with Desmos just a second ago. Hit the second key, then the table key. Let's delete all these values here, and we'll plug in the same test values. -9, -3, 0, and 7. And it doesn't matter if we're getting -285 or -285 million. All that matters is that it's negative. That's what we're looking to find out. And then positive, negative, positive. So you're getting the same information here that I showed you on Desmos. That, oh, it was negative here, it was positive here, negative, and then positive. So your final answer then is negative infinity, or excuse me, -8 to -8/3 union 6 to infinity. Those are the intervals that satisfy the inequality. That's where this graph is greater than or equal to 0. And you can see it pretty nicely here, but you don't have to envision it based on the graph. What I would suggest is that we just work on this with testing points. So, comments or thoughts on this? Maybe some of the technology they went over a little too fast. You able to get this on your graph, or at least on Desmos. So to kind of summarize what we're going to do when we solve these things, we're going to first factor our polynomials and then find where the polynomials are equal to 0. That gave me these points. These points separated my line into intervals. Those are your intervals here in green. And decide which intervals satisfy the inequality, we use test points to decide if the function is positive or negative in that interval, and then choose the appropriate intervals. So we're going to do the same thing with example C here. Now this kind of stuff is stuff that my calc students would appreciate a review on, deciding where things are positive and negative, because soon enough they're going to have to do that to try and decide where functions are increasing and decreasing, and then find minimums and maximums, etc. All right, so example C. So our inequality then is going to be x plus 5 squared times x plus 2 times x minus 1. And I want to know where that's greater than 0. Now the fact that it's greater than 0 is actually going to mean, you know, there's a little something we're going to have to take care of with our intervals that's different from our first example. But let's find out where this is actually equal to 0. And I'm hoping that you can read this off. When, what values of x make this equal to 0? Someone make me look good for our YouTube audience. No one?
-5.
All right, cool. -5. Keep going. -2. And 1. Thank you for being able to read that. That was not all that legible. All right, so those are the points that we're going to put on a number line. Those break up our number line into intervals. So when you're drawing your number lines, just label the points that you need. We want points at -5, -2, and 1. Now, because we're looking for where this is greater than 0, I'm not going to actually include the endpoints of these intervals. So I'm just going to write it all with parentheses. This first interval is -infinity to -5. Then -5 to -2, -2 to 1, and 1 to infinity. So those are the intervals. We've got to decide which one of these intervals we want. Which one of them satisfies the inequality. So, okay, I need some test points. Those test points have to be in the interval. Don't choose test points that are kind of at the edge of the interval. Choose test points on the inside. Leo, some help.
-4.
-4 would actually be in here.
Yeah.
Okay,
I guess like
keep going.
-7.
-7, good.
0.
0 is always a good one.
3.
3, nice. So those are going to be our test points. Thank you so much. Make sure that you change your function. The function that we're going to put in to your calculator to test these things is going to be this one here. So input this into your TI. So put into the TI 84 or similar. So let's do that. So I'll change up my function here. I'll just clear this stuff out. And it's okay to have it factored. Your calculator doesn't care. X plus 5 squared, x plus 2, and x minus 1. Nice. Again, I'm not going to worry about trying to visualize the graph. You'll see when one of our examples coming up that sometimes it's just really tough to do that. So we're good here. Let's give Leo's test points a shot. Now I'm going to delete all these old values here and just type in the ones that Leo suggested. So it would be -7, -4, 0, and 3. Nice. What's the relevant information that I need to get out of here?
If it's negative or positive.
Yeah, if it's negative or positive. So let's label those things. It was positive, positive, negative, positive. Now if you're thinking, well, gee, on the last one they alternated, yeah, that's typically what's happened. But that's not what happened in this case. Okay, no big deal. Which intervals satisfy our inequalities? Which one are we going to have as part of our solution? Positive. It's kind of funny. I was looking at both of you and thinking, well, I'll just ask for Ms. Walker to answer. So, yeah. No. That's like both of you, right? Yeah. Yeah. So, anyways, let's see. So yeah, we want the positive intervals, which would be this one, and this one. So your answer is -infinity to -5, union. Now on WebAssign you probably put a comma. -5 to -2, union 1 to infinity. Nice. How would this change if this problem was a greater than or equal to?
Maybe brackets instead of parentheses on the.
Yeah, brackets instead of parentheses. Thank you. So, and now that would mean kind of a funny little thing here. You'd have -5 or -infinity to -5 and then -5 to -2. You might as well just make that one whole big interval at that point. All right, but yeah, it'd be brackets versus parentheses. Thank you. Okay. Now things get a little bit messier when you're dealing with an inequality. There's one or two extra steps to kind of keep in mind. So let's take a look at example D. Two x plus 3 over x squared plus 4x minus 21. And I want to know where that's greater than or equal to 0. Well, we're still going to set up points where things are equal to 0. But the points that we got pretty easily up here are going to require a little bit more work for this one. I want two sets of points. I want to first find where the numerator equals 0. So that's 2x plus 3 equals 0. And the denominator equal to 0. So x squared plus 4x minus 21 equals 0. Well, this first one I'm hoping is not too bad. That's x equal negative 3/2. Do I need to bust out the quadratic formula for the second one? No. No, I don't. So, how's it factor?
7, x minus 3.
Yeah, thank you. X plus 7 times x minus 3. So what two solutions did it give me?
-7 and +3.
Yeah. X equal negative 7, x equal positive 3. Now I want to take note of something important here. That is, these are points where the denominator is equal to 0. If you were to graph this, there'd also be points where you have a vertical asymptote. Okay, nice. But are these points in the domain of this function? No, you can't put these into the function. So even though this has a greater than or equal to, we can't include this point or we can't include this point. Neither of them. Can you include this where the numerator is equal to 0? Sure. You just can't include the points where the denominator is equal to 0. So let's put out our number line, and then I'm going to draw our intervals as well. So nice long number line here. We've got points at negative 7, negative 3/2, and positive 3. And I don't know, maybe you want to give yourself a little bit of a reminder or something like that. We can't use points at negative 7, nor can we use points at 3. So the intervals that we get are going to be negative infinity to negative 7 with the parenthesis, because I can't use that negative 7. How about the next interval? What should that one look like?
-7 to -3/2.
Negative 7 to negative 3/2. Brackets or parentheses? Or kind of both, right? Go ahead, Liv. What do we get on the left-hand side?
Parentheses
Parenthesis.
and bracket.
Well done. Parenthesis and bracket. See if you can't finish up the last two intervals. And I think Nolan's going to give them both to us, but he's going to patiently wait for a second to give everyone a chance to think about things. What you got? So negative 3/2, bracket or parenthesis. Can we use it? Yep, bracket. Then to what? Bracket or parenthesis? Parenthesis, because we can't use the 3, that makes the denominator 0. And, well, we can't use the 3 here. And infinity and negative infinity always get a parenthesis. So there you go. The reason I want you to write these things down here is because at this next step, we're going to do our test points, right? I need some test points. And you fill in those test points. But when people don't write down these intervals, a lot of times there's a tendency to mix up these intervals with intervals that you're getting based on your test points. They use these numbers to form their intervals as opposed to these up here. your answer is going to be one or two of these things right here. We just got to figure out which ones. So let's go over inputting this stuff into your calculator. There was some, hiccups on this on the exam that you're getting back today. And I'll show you two different ways. Now, one of them is just kind of like the standard way, where you're going to take this divided by this. But where you got to be careful is you got to put parentheses around the entire numerator and the entire denominator. So parentheses, 2x plus 3 divided by. And let me take note of the fact for you that you have this factors in the denominator is 2x plus 3, x plus 7 times x minus 3. Now, if this were you on an exam or someplace else, you'd probably just use this denominator as is. But on the exam you're getting back, you had something that was closer to this. And let me show you what you'd have to do with something like this. So for that one, you need two sets of parentheses, one for the entire denominator and one for your first binomial, x plus 7, parentheses, and then your x minus 3. So if you're putting it in this way, you got to be careful to put parentheses around your numerator and denominator, otherwise it's just not going to give you what you're thinking. Now, here's a nice workaround for those of you who have a nice up-to-date calculator. If you've got one of the fancy ones, you can do this. Hit the alpha key and then the x key. And that gives you a nice horizontal fraction. And so now you don't have to worry or fuss as much about the parentheses. So it's going to be 2x plus 3 over, and I'll just type it in the way it was to begin with, x squared plus 4x minus 21. So both of them will work. You just got to be careful about inputting into your calculator. Let's go to the table. I need some test points first, though. What would be some good test points for us here?
Negative 8.
-8. Sure, -3. Where it changes signs, goes from negative to positive, 0. Yeah, -1, 0, both of them will work. And then how about something to the right here? 4. You could use 4 million, but look, you don't get bonus points for making it hard on yourself or the calculator, so let's keep it easy. Second table,
You got a 3 on top of the fraction.
thank you. Go to, oh, there it is. Thank you. There we go. Let's delete these, and let's type in our test values. So it's -8, -3, 0, and 4. Now both of these are giving us the same information. We just need to know where it's positive or negative. And in the first one, you get negative, then positive, then negative, then positive. A lot of times they alternate, and that's fine. So it was negative, positive, negative, positive. Let's write that down. Negative, positive, negative, positive. So, okay. Which interval or interval? Or which interval or intervals do we want? Do I want the negative ones or do I want the positive ones? Yeah, positive. I want to know where it's greater than or equal to 0. So the positive intervals, that's going to include this one and this one. Those are the intervals that I want. So my final answer is going to be -7 to -3/2 union 3 to infinity. Well done.
Mr. Parent,
Oops. I made a typo here. Should be a parenthesis there. Yes. Liv, is that what you're going to say? Yeah, thank you. Thank you. Now, it actually does dovetail very nicely with what I was going to say. Let's take a look at the endpoints. Let's actually put those in just for giggles. So, in my table, let me clear out all these values. Delete, 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 delete. And let's start by plugging in negative 3 divided by 2. Now it's immediately going to change that to negative 1.5. That's okay. But I get zeros here. Is 0 less than or equal to 0? Well, yeah, it's kind of a silly statement, but yeah, it's true. So I can use the endpoint at 3/2. But plug in negative 7. Tell me what you get when you plug in negative 7. What's your calculator telling you?
How do you get to this part of
The,
like where you can edit it?
so you got to make sure that your table settings for the window are set up. So if you hit second and then window, that gives you your table setup menu. And you should have independent set to ask. So go down and then cursor to the right, press enter. And then dependent should be set to auto. And once you have that set up, then you can hit the second key, then the graph key. And then now you can put in whatever values of x that you want. For instance, negative 3 here. No, it was positive 3. Positive 3. What's going on here? My calculator doesn't like me anymore. Why is it giving me this negative feedback?
Because this is where the holes are.
It's where the holes, it's where the asymptotes are, all right? So it's where the asymptotes are, but also you're trying to put in a number that makes the denominator 0. Your calculator doesn't like dividing by 0, all right? You can't divide by 0. It's telling you in its not so subtle way by screaming out error that you can't use these points. You can't use a negative 7. You can't use a positive 3. So if you're unsure, you could always test the endpoints, but hopefully you'll be able to just look at that and decide. Okay, any other thoughts on example D? I actually guess that was example E. My bad. Example E. So that takes us to example F. So example F asks us the same kind of thing, except this time we want to know where something is less than or equal to 0. Example F, x over x squared plus 2x minus 1 is less than or equal to 0. And it's going to be the same kind of thing that we saw in the last part. That is, I want to know where the numerator equals 0 and for the denominator equals 0. Okay, oops, wrong way. So we'll split it up. I'll do the numerator equals 0. You do the denominator equals 0. Equal division of labor, right? Maybe not. All right, so, well, x squared plus 2x minus 1 doesn't factor. So what's your options then? What are you going to do? Okay, good. Quadratic formula. I was hoping somebody wouldn't say phone a friend, and good job, quadratic formula. So, let's see. All right, so we're going to have to use the quadratic formula. Just a reminder, that's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's think, what are we going to get here? What's A for this one? 1. And B is 2. And C is negative 1. Awesome. Thank you so much. when you fill in the quadratic formula, it's not a bad idea to fill it in with big parentheses like this. And the reason I suggest filling it in with parentheses is because when you have negatives involved, it's easy to make a mistake, especially if you have a negative b. We'll start out with that b. It's negative of 2. 2 squared minus 4 times a, which was 1. Let's give me another a there. And finally, we get to use that c up there. This is going to simplify to negative 2 plus or minus the square root of 8 over 2. We can work with that a little bit more. In fact, I kind of expect you to. It's in your best interest, though. How can you break up 8?
Take out 4.
Yeah. This is the square root of 4 times the square root of 2. Square root of 4, I don't think I need to bother you with. That's just 2. And now there's a couple ways you can play this. It kind of depends on you. Personally, for my own reasons, I think that you should factor out the greatest common factor in the numerator. I'm just going to factor out the 2. It leaves behind negative 1 plus or minus the square root of 2 over 2. And now you can cancel. You can't cancel this 2 into that one or this 2 into that one. It just doesn't work that way. But now that I've rewritten it, now I can cancel. So what are we left with? We're left with negative 1 plus or minus the square root of 2. Okay. Or another way you could play it from here would be to do negative 2 over 2 plus or minus 2 square roots of 2 over 2. And that reduces the same way. Negative 1 plus or minus the square root of 2. Gosh, it feels like we should be done, right? We've done a lot of work. It's like, whew, get the oxygen bottle out, man. Need to draw off that. Well, unfortunately, it's just like a little part of what we had to do here. So, in case you're worried, I don't put problems like this on an exam. The problems that you're going to have are going to be kind of gentler problems where these things factor in the denominator. So, this one's a little excessively long. You guys had a look on your face that said, well, I kind of want to see where these come from. Initially, I had planned on just saying those are the solutions, but it's good practice to look at the quadratic formula. But that gives us our 3 points. We've got x equals 0, negative 1 plus the square root of 2, and negative 1 minus the square root of 2. So let me put those points on the number line for us. Let's see. 4. So the roots are at 0, negative 1 plus the square root of 2, and negative 1 minus the square root of 2. It's probably not a bad idea to figure out some decimal values for those things. You can take them off of your calculator. Negative 1 plus the square root of 2 is going to be about 0.414. Negative 1 minus the square root of 2 is going to be about negative 2.414. But again, just get those from a calculator. And we're going to put test points on our line here. Let's put all these points on that line. So I'm going to have one here at 0. I'm going to have another one here at negative 1 plus the square root of 2. and then -1 minus the square root of 2. And the reason I wanted you to put the approximate values here is so that you can come up with test points that'll work. If you're watching this later, maybe pause the video, try and come up with the intervals that you're going to use here. Remember, our inequality was a less than or equal to. We're trying to solve where x over the x squared plus 2x minus 1 is less than or equal to 0. So what intervals do we want to use here?
Just curious about that. Oh, that's one of the kids I graduated with. High school both Western Michigan. Cool. That's my age.
I would just want to see something.
That are created by these numbers up the left of -1 minus the square root of 2.
It's not a bad idea to think about. You don't have to. Not a good test point numbers. Because that would make the denominator 0. Oh, right. Can't look like that. Okay, so the intervals that you should be playing with are created by these points. So I'll start at -infinity, and it's going to go to -1 minus the square root of 2. But is that minus square root of 2, is that getting a bracket or parenthesis there? Jude? Parenthesis. Yeah, we don't want this point because that makes the denominator 0. Likewise, on the other side of it, well, we still don't want it. Up to 0. Bracket or parenthesis on the 0. Tony? Anthony? Bracket or parenthesis? Dominic C?
Bracket.
Bracket. Nice, thank you. And then likewise a bracket over here. -1 plus the square root of 2. Bracket or parenthesis? Parenthesis. And then one more parenthesis as we go on all the way out to infinity. Now we're going to need to do our test points. So that's why you put in these numerical approximations. Some good test points, I don't know, probably -3, -1. This one we got to be a little bit creative, don't we? What's between 0 and 0.414? Yeah, 0.25, sure. And finally, maybe a 1 would work there, a 1 or a 2, whatever you're comfortable with. So those would be our test points. Let me put that function into our calculator. That's another easy mistake to make, is not changing the function in your calculator. Let's clear out those. And I'm just going to do it this way. X divided by parentheses around the entire denominator. X squared plus 2x minus 1. Let's put in our test points. -3, -1, 0.25, and 1. Oops. 0.25 and 1. So negative, positive, negative, positive. Oftentimes, that's the pattern that you're going to see. So negative, positive, negative, positive. Which ones do we want? Do we want the positive intervals or the negative intervals? Negative intervals. Thank you. So that one and that one. Those are your answers. So, answer. But your answer is going to be intervals. Please don't just stop when you find these numbers. All right? You're really missing a lot of the problem if you do that. Union 0 to -1 plus the square root of 2. And also another place to lose some easy points that I want you to is by not putting in the correct brackets or parentheses. Okay. Comments on that one? We've got 2 more here.
I have a
Sandals?
question, yeah.
Sure, please.
No, not question. Can you repeat the part when you figure out where it's like parentheses and where it's the bracket?
Sure, sure. So, what the points that we can't use are points that make the denominator 0. Now, when we first started this problem, we actually solved a quadratic equation to figure out the points that made the denominator 0. So that was these points. So -1 plus or minus the square root of 2. If you notice, and maybe I was kind of subtle about it, but I circled those points just to say, okay, we can't use those. Maybe on the flip side, I could have also put a solid dot here saying, okay, we'll use that one, but not either of these. So because I can't use it, I'm using a parenthesis around it. That doesn't include this. Same thing here. Bracket says, yeah, you can include that point. So we can use the 0. We can't use the -1 plus the square root of 2, for instance. Now,
We don't have a like denominator. It's gonna be like if it's less than an equal or more than an equal, it's gonna be all different.
nice observation. So, yeah, going back to our first one here, notice everything was brackets. That's because we had a greater than or equal to, and we didn't have to worry about anything in the denominator being 0. So, yeah, it's all brackets for these because of that. So it's kind of nice. You can kind of confirm things, though. If you're not sure when you're all done, it's like, should that have a bracket or parenthesis? Should that have a bracket or parenthesis? Let's go here. You could type in a 0, and that works. 0 is greater than or equal to 0. But if I try typing in -1 plus the square root of 2, and sometimes it doesn't exactly work, but I'm hoping so here. Yeah, it's telling me error. And that's really saying, oh, you're trying to divide by 0. You can't do that. Don't use that point because it creates problems. Jude?
Maybe a stupid question.
No, I appreciate all questions. I really do.
How did you get 0 for root? I see how you got the other 2.
Sure.
But
No, it's a good question. It's curious for you. Then let's tackle it. Let's see. When we start out, I want to know where the numerator is 0 and where the denominator is 0. The numerator is 0 when x equals 0. So, yeah. But I appreciate that you asked it. Any final thoughts for example F? All right, like I said, I'll make these a little bit easier. These problems are long enough without making you do the quadratic formula here. So Little sigh of relief there, hopefully for you guys. Let's finish this up. We've got two more. Can anyone just look at this graph and tell me where f of x is greater than g of x? What intervals? It's kind of tough. So our f of x function would be this one. This would be our f of x. And then this one would be f of x here. So that's our f of x. But it's kind of tough to tell, well, what intervals solve this. This is why I'm suggesting that when you do these types of problems, that we're just going to do it by testing points. The graph here is really difficult to work with, even for myself. I remember looking at this when I was getting the handout ready and going, you know, I'm glad we're testing points on this one. Now, there's a little bit extra work here because I want to know where the graph of f lies above g. Now, what that's going to translate to is something like this. F lies above g. That's going to mean 1 over x is greater than 1 over x minus 1. That's the inequality that you're trying to solve. So so this is saying solve this inequality. Okay. So example G. We want to know where 1 over x is greater than 1 over x minus 1. Now this is something that you may see, you know, depending on if my favorite team won the game the weekend before or not. All right, just kidding. But it is a little bit extra work compared to some of the previous problems that we did. There's 2 extra steps. So first of all, you want to get 0 on one side. So that's not too bad. Get 0 on one side. Okay, that's easy. I'll just move the 1 over x plus 1 term to the other side. I get 1 over x plus 1 over x minus 1. And I want to know where that's greater than 0. So you're like, whew, dodged a bullet there. But here's where the real work comes in. You have to write the left-hand side with one rational expression. So write the left-hand side with one fraction. Okay, well that's kind of a bummer. In order to write this with one fraction, what am I going to need? Can anyone tell me? And just in words, you don't have to tell me what it is, but yeah, you're going to need a common denominator. So our LCD for this one is really going to be a product of two things. Because I got a denominator here and a denominator here. So my product of those two things is really going to be x times x minus 1. That's my LCD. Now as I look at these fractions, what am I missing here that I have as part of my LCD? X. So I'm going to multiply by x over x. Will, how about over here in this first one? What should I multiply this one by? X minus 1, x minus 1. Thank you. So that gives me x minus 1 over x times x minus 1 minus x over x times x minus 1. I still want to know where that's greater than 0. Okay. I've got common denominators, right? So I can combine the numerators, x minus 1 minus x over x times x minus 1. Okay. Can I simplify that at all? Can you see any simplification for me?
Cancel out the x's.
Yeah, let's get rid of the x's, right? That one and that one disappear. So I'm just left with negative 1 over x times x minus 1. And I want to know where that's greater than equal or greater than 0. So a lot of extra work there, right? So not much we can do about it. You still got to work through it. But let's see about solving the rest of this. Remember, I got to solve where the numerator equals 0 and where the denominator can equal 0. At least that part's a little easier. Does negative 1 equal 0? Not last time I checked. So we're out of luck there. But how about the denominator equals 0? Where's that going to happen?
1.
Good. 1 and what else?
0.
Yeah, 1 and 0. And that's it. We don't get anything from the numerator. That's fine. So let's put this on the number line like we've done with all our other ones. There's only 2 points that we got to worry about. One of them was 1, and one of them was 0. So at 0, we got a point, and at 1, we've also got a point. Why did I bother drawing these with hollow dots?
They're asymptotes, so they can't be.
Yeah, they're asymptotes. If you look at the graph is undefined at 0 and 1, so those can't be part of any solution. And kind of going back to Zandos' point, you know, when you have greater than or less than, you know, everything's going to get parentheses. So it's going to be negative infinity to 0, 0 to 1, and 1 to infinity. And now we need to test points. I think this one's going to test out negative, positive, negative. Not sure. Let me just run it through. Let's clear out all this stuff here. Negative 1 divided by parentheses. Let me just call it x squared minus x. It's not treating me right. X squared minus x. There we go. I need to be a little bit careful with our test points. Certainly you can choose like negative 3. But how about our middle interval? What am I going to choose there for our test point? Negative 3. Lena? Yeah, 1/2, and then say maybe 2. And I think we're going to end up with a positive and then a negative. So I'll put in a 0.5 here and 2. So negative, positive, negative. So this is your answer. Right there. 0 to 1. Boy, it's not easy to tell from the graph that that's actually the case. That between 0 and 1, this is greater than this. I mean, in hindsight, it's a little easier to see. But it's tough to solve that just based on the graph. That's why we've been doing things by testing points. Because it's just difficult to do this by work on the graph alone. Okay. The last one, is just a little bit of a reminder on how to do things with inequalities. This represents the flow of traffic that you get on a highway. So you have a civil engineer that's working on this. We want to know for what values of x is this greater than 40. So if you're to graph it, you're going to get some graph like this. And what our job is to find out is what are these points where this is actually equal to 40. So we're going to have to put in a couple things. We're going to have to put in this function, we have to put in this function, and find out where this is greater than or equal to this. So let me help with that. And then we'll call it a day on this section. I think the easiest way to put in this function is at the alpha key and then give yourself a nice horizontal fraction. 88x over 17 plus 17 times parentheses. And then I'm going to hit this little alpha key again to put in that x over 20. X over 20. Right arrow to get out of the denominator, parenthesis, and then the square key. So there's the first one. The second function you're going to put in is y equals 40. Okay. As far as the graph is concerned, let's set up our graph between, let's see. Usually I have some suggestions here, but I didn't put any suggestions down. That's going to be a kind of bummer. So for my window, I'm going to go between, let's see. Let's go -5 to 55 maybe. We'll see how that goes. X scale, I'll make that a 5. Y scale, I don't need to see this below the x-axis. So if you want to, you can make a -2. That way you can actually see the x-axis. But we'll go up to 50, maybe 60 should work. And if you're curious as to where and why I'm getting the 60, this graph goes a little bit above 50. So that's why I'm going a little bit higher. With those settings, hit the graph key. You see them come up one at a time. And there you go. To answer this question, we need to find the points of intersection. Now, I gave you the commands here on your sheet in case you forget them. You want to hit the second key, then the trace key, and then option 5 is going to give you the intersection. So if you need to remind yourself when you're looking at this handout later, there it is. So let's just clear that off and do exactly just that. Second key, trace key, option 5. Now, if you're trying to find the intersection, it's going to ask you, well, get close to it. Get me close to that point of intersection. And you can be to the right, you can be to the left, doesn't really matter. Just get close to it. Now, once you get close to it, you're going to have to press the enter key 3 times. Because really what it's doing is it's saying, what's a guess from the first curve? You press enter and you give it that. And then you do likewise for the second curve. And then once an initial guess, just press enter one last time. You should get about 9.4538. So we'll do 9.45. That's close enough. And now for yourself, finish this off by trying to find that other point of intersection. So hit the second key and the trace key, option 5. Get close to that second point of intersection and press enter a total of 3 times. Got it. Nice. Nice. Okay. So let's take a look here to finish this off. Press enter, enter, enter. I get 42.31. That's the other point. 42.31. This is going to be greater than 40 in this interval. So if I want to write that interval in interval notation, it's going to be 9.45 to 42.31. And that's it. Thoughts on the last one? All right. All set then.